we have the x and y components of vector p shown in figure 411 are given as, so here's my x, and I'm just going to write 6 here for my y. Here's my triangle here, and this is my reference angle. Find the magnitude and direction and write the vector p in rectangular and polar form. Well, now we don't have everything we need for polar. We do have everything we need for rectangular this time. If I want to do my rectangular first, which I might as well since I know everything, I know that vector p is going to equal negative 4.5 I plus 6j, because it's just the components of the triangle. Now I have to convert it into polar. How do I convert it into polar? I have to find p, because polar is going to be r comma theta, or in our case, p comma theta. Well, the easiest thing for me to do first is find the reference angle. And to find a reference angle, I'm going to use this triangle here that I'm kind of highlighting in blue. And I know y, and I know x. If we're using our reference angle, y is always opposite. Opposite is 6, and adjacent is negative 4.5. Even though my values are negative, I really want the reference angle. So I'm going to ask for the inverse tangent of y, which is 6, over x. Even though it's negative, I'm going to make it positive. And I'm going to find that value. If you want to take out your calculator, I'll take out mine. Make sure your calculator's in degrees, because we're working in degrees. If it's in radians, you're going to get an answer in radians and you won't understand it. I get this as 53.13 degrees, which is equal to my reference angle. It is not the angle I'm looking for, because the angle I'm looking for is right here. What I want to do is I want to find theta, not theta sub r. This is 0 degrees. This is 180 degrees. This is just a little bit of geometry. Theta plus theta sub r is equal to 180 degrees. So if I want to find theta, I would just subtract my reference angle from 180 degrees. Another way to look at it, if you feel very comfortable with trigonometry, is I'm starting here. I'm going all the way to 180 degrees. That gets me here. And then the next thing I'm going to do is I'm going to back up to here, which is a negative angle. So the yellow is a positive angle, so I have 180 minus the reference angle. Now we can figure it out. We just take our number and we subtract it from 180, and our value is theta is equal to 126.87 degrees. And now I can write it in polar. Polar, I would have r. Did we find r yet? We did not. Okay, we have to find r. So we're missing that still. We don't know the length of that vector. And theta, which is, we do know, 126.87 degrees. And again, there's a bunch of ways we can figure out what p is, but I think the easiest is just using the Pythagorean theorem. We know that to find p as a value, we want the magnitude of vector v. Sometimes we write it with 1, and sometimes we write it with 2 bars. but whichever way you see it, it's the magnitude, it's the length of that line. I have my direction, I have to find my magnitude, and again, I have X, I have Y, and basically I need to find, if we call this H, we can say that 6 squared plus 4.5, because I'm squaring it, I don't need to make it negative. If you want to make it negative, you can, and then square it and it'll become positive anyway, is going to equal to, actually, let me call it R since we're talking about polar. We'll call this R. So this is going to equal R squared. And that gives me 36 plus I have 0.5 squared is 20.25 is equal to R squared and plus 36. So this is 56.25. I'm going to take the square root of both sides. So I get R is equal to 7.5. 7.5 is my R. And I've now done it. The same type of problem, only given different information, going back the other way.